I'd like to continue on with this salary example, but I need to expand on what we can do. So we already know basically how to find any probability that we might need, whether it's less than a number, more than a number, between two numbers. That's all we really ever would need for this probability stuff with the normal distribution. But there's one other thing which is basically like the inverse of what we were just doing. So let me show you an example of that. So now we say one of the managers says she makes more than 95% of the other managers in her position. What must her salary be? Okay, well, that means there's a 95, if we just randomly select a manager, that means there's a 95% chance that their salary will be less than hers. That's actually how percentiles work in probability. So before, when we looked at percentiles for samples of observations, it meant that if you're at the 95th percentile, 95% of the data is less than that. Well, there's no data here, right? It's probability, so we're just looking at what could happen. And what could happen with the 95th percentile for probability is that there's a 95% chance that my next observation will be less than that, and a 5% chance that it'll be more than that. So it's just switching from how much of the data is less than that to what the probability is that it's less than that. So what we're really looking for here is the 95th percentile, right? That's where there'd be a 95% chance of being less than that. So we've still got these same distribution of manager salaries with $70,000 as the mean. And remember I said the mean is the median, so we know that this is the 50th percentile right here, right? There's a 50% chance of being less than that. So the 95th percentile must be over here somewhere. I don't know what it is yet, but I know the area right here is 0.95. Because there's a 95% chance of being less than this 95th percentile. So basically, instead of having this number and then finding the area to the left of it, I have the area, and I want to know what this number must be. That's why I say it's like the inverse of what we did with probability, where we usually had this number and then wanted the area. So let's just go into Minitab on Windows, and again in the lab it'll show you that this is extremely similar on a Mac or Chromebook. So I'll go into Minitab here. I'll go to Graph, Probability Distribution Plot. I'm still going to view a probability. It's still the same normal distribution with 70,000 and 4,000. The only thing is, instead of defining the shaded area by a particular x value, I'm going to define it by a probability. And specifically, it's the area to the left of this number is what I'm looking for. I'm saying the area to the left of whatever number this is 0.95. So I'll put in 0.95 for my probability in the left tail, and it'll tell me what x value that must be. So this area is 0.95 to the left of $76,579. So if her claim is that her salary is higher than 95% of the other managers, that must mean her salary's at least $76,579. All right, so now you know how to deal with percentiles and probabilities. Now you can do just about everything I'd ask you to do with the normal distribution for individual observations like this. Now we're going to move on, or in the upcoming videos, we're going to move on to talking about groups of observations instead of just one.